Have you ever looked at a spreadsheet full of numbers and just seen, well, a bunch of noise? Today, we're going to put on our detective hats. We're diving into a story where the clues aren't fingerprints or footprints, but data points. Our mission? To crack the code that's hidden inside the numbers.
So let's just jump right in. You get handed a big pile of data. At first, it just looks like a jumble, right? It can feel a little chaotic, maybe even intimidating. But here's the secret. Buried inside all that raw data is a story. There's a truth just waiting for us to find it.
And here it is. This is our case file. We've got the test scores from two different 8th grade classrooms, 105 and 106. The principal wants to know something that sounds simple. Which class did better? But just looking at this list of raw scores, it's pretty much impossible to say, isn't it? This is exactly where our investigation kicks off.
So yeah, we're not just looking at numbers here. We are absolutely solving a puzzle. The goal is to get past this initial mess and find a clear, confident answer for that principle. Every good detective starts with the most obvious clue. And in the world of data, that's the average, or as the pros call it, the mean. It's always the first tool we pull out of our detective kit. Now, the mean is a really powerful first step because it takes that whole long list of numbers and just boils it down to one. It gives us a single number to represent an entire group, which makes comparing things seem super simple. And boom, here's our first big clue. After we run the numbers, Classroom 105 has an average score of about 81. Classroom 106, they're sitting around 74.5. So based on this one clue, it looks like Classroom 105 is the clear winner.
But hold on, a good detective never ever trusts the first clue completely. Is the story really this simple? Or could the mean be hiding something important from us?
And here's the secret weakness of the mean. It can get pulled around really easily by extreme values in the data. We call these unusual suspects outliers, and they can totally warp the picture, leading us down the completely wrong path. And when we look closer at our data, yep, we spot them. You see that score of 45 in Classroom 106, or the 55 and that 99 in Classroom 105? These are our outliers. Just a couple of really low or really high scores can drag the entire class average up or down, totally masking what's actually going on with most of the students. So, to get past this distortion, we need a more reliable tool. It's time to dig a little deeper and find a way to measure the center that isn't so easily fooled by these outliers. Let's bring in our next tool, the median. It's actually super simple. You just line up all the scores from the lowest to the highest, and you pick the one that's sitting smack dab in the middle. The beauty of the median is that it just ignores those extreme scores on the ends. It's only interested in the true center of the group. So here's the key difference you gotta remember. The mean gives you the average value, which, as we've seen, can be really misleading. The median, on the other hand, gives you the score of the middle student. It gives you a much more stable picture of how the typical student performed. Any good data detective is always going to look at both. And whoa, this slide really drives the point home. Look at Classroom 105. The mean and median are pretty close, right? 81 and 80. But check out Classroom 106. Its mean was down around 74.5, but its median is 75. The median is actually higher than the mean. That's a huge clue. It tells us that the low average was probably caused by a few low scores, but the typical student in that class actually did a little better. We've got one more tool to find the center, the mode. This is the easiest one of all. It's just the score that shows up most often. In Classroom 105, the most common score was an 80. But look at Classroom 106. It's a tie between 75 and 85. That's another interesting clue, suggesting there might be two different performance groups within that one class. Okay, so we've got a way better idea of the center now. But you know what? That's only half the story. To really understand what's going on in these classrooms, we also need to know how consistent the scores were. Were they all packed tightly together, or were they just spread all over the place? And this is such a critical point. Think about it like this. Imagine two archers. Both of them might hit the bullseye on average, but one archer might have all their arrows clustered right in the center, while the others are scattered all over the target. See? Same average, but totally different levels of consistency. That's exactly why we need to measure the spread. The simplest way to measure spread is called the range. It's just the highest score minus the lowest score. For Classroom 105, that range is 44 points. That is a huge gap between the top student and the bottom student. It tells us right away there's a lot of variability in that classroom's performance.
Now, for a more powerful measurement, we use something called standard deviation. I know it sounds complicated, but the main idea is actually pretty simple. It tells us, on average, how far away each student's score is from the class average. A small standard deviation means everyone's scores are tightly clustered together. They're consistent. A big one means the scores are all over the map.
The formula for this can look like a real monster, but it's really just these 4 steps. First, you figure out how far each score is from the average. Second, you square that number, which basically just makes everything positive. Third, you find the average of all those new squared numbers. And finally, you just take the square root of that. It's a super precise way to measure how consistent a group is.
All right, we've gathered all of our clues: the mean, the median, the range, the standard deviation. Now, it's time. We're going to put it all together and finally see the whole picture. This is the moment we crack the case wide open.
To pull it all together, we start by making what's called a frequency table. Instead of that long, messy list of scores we started with, we just count how many students got each score. See? Now we can clearly see how many got a 70, how many got an 80, and so on. This is the first step to seeing the real shape of our data. And now for the final review. We take that neat little table and we turn it into a picture, a type of bar chart called a histogram. This one visual tells the entire story in a single glance. We can finally see the center, we can see the spread, and we can see the outliers. The numbers have finally become a clear, understandable shape.
So, what's our final verdict for the principal? Well, it's not as simple as one class just being better. Classroom 105 did have a higher average, sure, but it was also way less consistent, with a massive gap between the high flyers and the strugglers. Classroom 106 had a lower average, yeah, but that was mostly dragged down by an outlier. The bulk of its students were actually more consistent. They just tell 2 completely different stories.
And that brings us to the most important point of all. Being a data detective isn't about finding one simple answer. It's about learning to ask better questions. For Classroom 105, the principal might ask, how can we support our students who are falling behind? For 106, the question might be, how can we challenge this consistent middle group to aim even higher? You see, the numbers don't end the conversation, they're where the real conversation begins.